All right, we are going to be looking at some conditional probability today, which means that it's probability that has had a restriction placed on it or a condition placed on it. Okay? So, when you see conditional probability, it may look two ways. The first way, it might look like this, and this means that the probability of the second event happening, given that the first event has already happened. So you're figuring out the probability of this happening, knowing that this already has happened, which creates some conditions or some constraints, okay? So that's what's happening there. Basically, I like to think of this kind of as a fraction, you've got a little sentence there. It means that you're choosing the second event out of only the first event, not the entire group. And you'll see, I think, a little bit about what this means as we go through some problems. Okay, so we're looking at a deck of cards, and I first of all want you to figure out the probability that you're going to draw a heart given the probability that you would draw an ace. Okay, so here's the deal. You're drawing a heart out of only the aces. This becomes your bottom number. You're going to kind of think of this as a fraction. This is your denominator, which sort of makes sense if you flip that. There are 4 aces. And out of those aces, only one of those 4 aces have a heart on them. And so this has a 1 in 4 shot of happening. Okay? An ace given a black card. Again, this is going to be your bottom number. Okay? So there are 26 black cards. Now you're only drawing out of only those 26 black cards. That's it. Not the entire deck. The red cards are gone now. You can't think of that. So out of only those black cards, there's 2 aces. The ace of clubs and the ace of spades. So there's 2 out of 26 cards that are aces and black, and that reduces, of course, to 1/13. Okay, then the probability that you're going to get a 2, given that you have drawn a diamond. So this has to happen first, okay? You've drawn a diamond, that's happened, and now out of those diamonds, what are the chances that you get a 2? Okay, so there's 13 diamonds, and out of those 13 diamonds, only one of them has the number 2 on it. Okay, so 1/13. All right, back to these families of 2 children. You can draw a tree diagram if you need to, or you can kind of list the sample space and go from there, which I am going to do. So if you have 2 children, these are the things that can happen. You could have a boy and then a boy. You could have a boy and then a girl. Or you could have a girl and then a boy, or you could have a girl and a girl. And those are the only ways you can have 2 children. So the probability of having 2 girls, there's 4 options when you have 2 children. Out of those 4 options, only one of them has 2 girls. And so that's how that goes. You could also go like this. The first chance you have a child, there's a 1 in 2 chance of having a girl. And the second time, there's a 1 in 2 chance of having a girl. And that gives you 1/4. So that works for that. The next one, the probability that you're going to have 2 girls given that the oldest child is a girl. So this has already happened. This has to happen. And so you're picking out of only families where the older child is a girl. And so that would be this family right here, the older child is a girl, and this family right here, the older child is a girl. Those are the only 2 families you can pick from because that's the condition that's been put on you. And then out of those 2 families, only one of those 2 ends up with 2 girls. Okay? Then in the next one, having 2 girls, given that there is at least 1 girl. So this is the restriction that's being put on you. It has to be a family where there's at least 1 girl first. Okay? This family has at least 1 girl, this family has at least 1 girl, this family has at least 1 girl. This family can't count in that case because they don't have at least 1 girl. So out of those families where there's at least 1 girl, which there are 3 of them, one of them will end up having 2 girls. So you have a 1 in 3 shot of having 2 girls. All right, this time I'm going to give you a table, and you're going to kind of look at that. This table talks about people that like Chinese food and don't like Chinese food. Okay, so if you just ask the simple question, what's the probability if I chose someone at random who I polled that they would like Chinese food? Well, there's 306 people that like Chinese food, and there are 500 people total that's participated in this. So 306 divided by 500 reduces to 153 out of 250. Okay, I'm going to erase this so I don't get messed up for the future. All right, the next one, the probability that you like Chinese food given that you're 12 and under. Again, these are the only people you're choosing from. This is going to be your bottom number. I only care about people who like Chinese food if they're 12 and under. And so there's 103 people right here that are 12 and under, 103 of them. And out of those 103 people, I'm wanting to know how many people like Chinese food, and there are 21 out of that group of people that like Chinese food. So that's 21 out of 103, and that does not reduce. Okay, and then the last one, the person is over 12 given that they don't like Chinese food. So this is the restriction that has to happen. They can't like Chinese food, and that's going to be your bottom number. That's the people you're drawing from. So the people that don't like Chinese food are these people right here, and there would be 194 of them. And out of those 194 people, the people that are over 12 are 112 of them. So 112 out of 194. And that reduces to 56 out of 97. Okay. All right, and then another example. You're going to roll 2 dice. I want to know that the probability that the die has at least 1 3 on it, given that the sum of the die is 7. So this is the restriction I'm putting on you. It's 2 dice that have to add up to 7. So these are the ways that that can happen. You could get a 3 and a 4, or a 4 and a 3. You could get a 2 first and a 5 second, or a 5 first and a 2 second. Or you could get a 6 first and a 1, or a 1 first and then a 6. And those are all the ways that your dice can add up to 7. That's it. That's the only ways. So you have 6 ways that your die can add up to 7. And out of those 6 ways, you want to know at least the pairs that have at least 1 3 in them. And that would be this pair right here and this pair right here. So there are 2 out of the 6 ways, or 1 out of 3. Now, I need to tell you this real quick, because in your homework it might come up that, let's say this number was an 8. And if this number was the 8, an 8, you would go 2 and 6, 6 and 2, 5 and 3, 3 and 5. You can't do 1 and 7. That's it, okay? Now, the question becomes, can you do 4 and 4, or should you do 4 and 4 twice? And you need to remember that the way you list them, this means that I rolled a 2 first and a 6 second. That's what that means. This means I rolled a 4 first and a 4 second. If I list it again, does it mean anything different? And no, it does not, because it still means that I rolled a 4 first and a 4 second, which is exactly what this meant. So if you have doubles, only list them one time. Okay, only list them one time. All right, and then you're going to get problems similar to this in your accelerated math. So you have a class of 40 students, 11 honor students, and 13 athletes. 3 of those of the honor students are also athletes. 1 student is chosen at random. Find the probability that this student is an athlete if it is known that the student is not an honor student. And this gets to be a little bit tricky. But what I would suggest doing is drawing a handy-dandy little Venn diagram. And you know, I'm just going to put this number out here, that I have 40 students total that I'm dealing with. Some of those are honors students, which I'm going to call an H. And some of those are athletes, which I'm going to call A. And what I know is there are 11 honors students. So this circle right here has to add up to 11. Okay? And there are 13 athletes, so this circle right here has to add up to 13. And it says that 3 of the honor students are also athletes, so there's 3 that goes in the middle. Okay? Then we know that the honors circle has to add up to 11, so if there's 3 in the middle, then this is 8. And the athlete circle, this circle right here, if there is 3 in the middle, has to add up to 13, so this is 10. And now if you add 8 plus 3 plus 10, you know that there's 19 students out here that are not honor students or athletes. They're neither honor students or athletes. And 8 plus 3 plus 10 plus 19 adds up to the 40 total that you need. Okay? Now, the question becomes, find the probability that this student is an athlete if it is known that it is not an honor student. So on the bottom, what you need to do is you need to have those students that are not honor students. Okay? They can't be an honor student. If you look here, this number fits into the honor circle. That's not going to work. If you look here, that number fits into the honor circle. That's not going to work. These 10 people, though, however, are not honor students, and these 19 people are not honor students. So there's 29 people total that are not honor students, and out of those 29 people, you need to figure out how many are athletes, and there's 10 that fit into that athlete circle. So there's 10 out of 29 that are athletes. Okay? All right, 2 cards are drawn in succession without a replacement, so you're not going to put them back. Find the probability that the second card is a diamond if it is known that the first card was a diamond. Okay, so here's what happens. The first card being a diamond, there's 13 diamonds out of 52 cards. It's not being replaced, so the second time you have a 12. There's only 12 diamonds left and only 51 diamonds in the deck. What you're going to be tempted to do is multiply this out and get an answer and go. But all it's asking you is find the probability that the second card, that's all it wants to know about. It doesn't want to know the total probability. It wants to know the probability of the second card. And the second card is a 12 and 51 shot. And that reduces to 4/17. Okay? All right. Then, a math teacher gave her class 2 tests. 25% of the class passed both tests, and 42% of the class passed the first test. What percent of those who passed the first test also passed the second test? Okay, so here's the deal. To figure out the probability that they passed both, so I'm just going to kind of write this out so that you can think about this. To figure out the probability that they passed both would be the probability that they passed the first times, because it's an and event, they have to pass the first and the second test, and when you see and in probability, you multiply. They pass the first and then they pass the second. And you would multiply those two. Okay? Well, I know that the probability that they passed both of them is 25%. So I'm going to do that as 25. And I know that 42% of the people passed the first test. And the question is, I don't know what this is, okay? I don't know how many people passed the second test, but I know I'm going to take 4.42 times x and figure out how many people passed the second test. Okay, so to solve for x, I would divide by 0.42, and I would get about 59.5% of people. Okay, so that should do it for this lesson.